Lesson 5.4 is about compound inequalities. Yesterday we talked, what was one? I just showed it.
And or or.
And or or. Okay, about two different types. Talk about and first. What's special about and?
It connects.
It connects. Okay. What else?
Why'd you get rid of our greater than less than?
So, I'm going to pick random numbers. I'm going to have -2 and 6. Okay. What does the graph look like for and? Connecting, right? I'm just going to put closed dots for now. Connecting, their line is going to go all the way through. Because it's x is greater than -2 or equal to, and x is less than or equal to 6. Okay? Any questions on and? What was the second part of the and?
Rewriting it out.
Rewriting it as a compound, okay? Because remember, it's this and this. So it's one thing, okay? So remember, write it in numerical order, least to greatest. And then what signs go in the middle? They always point to the left. It's always going to be less than, okay? Because remember, this one matches, and then this one we got to flip. Okay? Questions with and. The way to check is to make sure your graph is connected. Okay? The other one was or. Oh, I have an example first. Sorry. Example. With and, we have two different inequalities. Just solve them both, one at a time. So on the left, what do I do first?
Add the 1 over.
Subtract the 1 over. So we have 2x is less than or equal to 12. Last step would be to divide by 2. So we have x is less than or equal to 6. That one's done. Okay, what do I do with the one on the right? Add 2. So I have 7x is greater than 0. Last step. Divide by 7. X is greater than 0. Okay, now we got a graph. So I'm going to draw my number line. I'm going to plot my points. Some of us were like, I'm going to put 6 over here. I'm going to put 0 over here. Why is that wrong?
Because 6 is
It needs to be in least to greatest order. So 0 needs to be over here. 6 is over here. Let's graph 6 first. Before graphing, what should our graph look like? They should connect, okay? So 6, open or closed? 6 is closed. In which way is our arrow going? Left. What's 0? Open or closed? Open, and it's going right. Is that correct? Yes, because it's connecting and it's and. What's the last step with and? We gotta write it out as a compound inequality. Remember, drop your numbers straight down, put an X in the middle. What signs go with the compound inequality? Less than, and then less than or equal to. Just make sure they match with what sign was with them. Questions on and? All right, look about or. What do we know about or?
They go in different directions.
They go in different directions. So if I have my -2 and 6, 2 goes out, 6 goes out. Because remember, there's that union in the middle. So if I write those inequalities, x is less than or equal to -2, and x is greater than or equal to 6. Now what this is saying is if we plug in any random number, we're going to get this or this. We can't have both. Does that make sense? So our answer is either going to be over here or it's going to be over here. You can't have both. Okay, that's why it's split. Do we have to rewrite the or statements? No, because they're not connected. Okay? So these are really just two inequalities on the same graph. Any questions with or? Okay. We're going to do an example. What do we need to do first on that left side? We need to solve it. What do we do first?
Add 10. 10.
Yep, add 10. Not in red. So I have 3x is less than negative 3. Last step. Divide by 3, we get x is less than negative 1. Okay, on the right, what do we do first? Subtract 10. So we have 2x is greater than 14. Last step. Divide by 2. We get x is greater than 7. What statement are we working with, and or? Or, remember, it's always going to tell you if it's and or if it's or. Okay, so what's our graph going to look like? They're going to go in opposite directions. So if I graph negative 1, 7, you're going to have 1 open or closed. Negative 1's open and it goes to the left. 7 is open and it goes to the right. Did we graph it correctly? Yes, because it's or. And there's that union in the middle. We can have this or this. Questions on or? Any questions before I move on to something new? Okay. There are special cases. What do we think those special cases are? There's 2. We can either have no solution. So this is where you want to start adding to your notes from yesterday. You can have no solution, or do you remember what the other one is?
Infinite solutions?
Infinite solutions, or I'm going to say all real numbers. Okay, we have no solution and all real numbers. Those are our 2 options. I'm going to come back to those. We're going to do some examples first to see which one's all real solutions and which one's no solution. Okay. Let's look back. No solution is and. All real numbers goes with or. Okay. I'm going to draw a graph to show you what it looks like. If we have and, we can't have this. That's no solution. If we have or, we have this. Questions on special cases? Are we feeling better with compound inequalities? Okay. This example, I'll give you some time to write this down. First off, how is this written? It's written as a compound inequality. So does that go with and or does that go with or? It goes with and because it's connected, it's together. Okay, so keep that in mind. This is and. Okay, so let's solve. How do we solve when it's all connected as one? Yep, we're still trying to get k by itself, but what we do to one thing in an equation, we have to do it to everything. So you're going to add 7 to all of those sides, okay? So on the left, we have 74 plus 7, which is 81. Left in the middle, we have 9k. And then on the right, we have 0. Everyone okay with that step? Okay, so what's our last step to get k by itself? Divide by 9, and we have to do that to everything. So now I have 9 on the left is less than k, which is less than 0. Is everyone okay here? Does that make sense? Looking at that, 9 is less than k, which is less than 0. Does that theoretically make sense? Why not? Because 9 is not less than 0. So before we try and graph, what do you think this is going to be? No solution or all real numbers? Right, because it doesn't make any sense. Okay, so let's try and split this up. So if I flipped it, we have k is greater than 9, and we have k is less than 0. Let's try and graph those. So I have 0 over here, and I have 9 over here. 9 has an open or closed? Open, and it's going to the right. 0, open or closed? Open, and it's going to the left. Is that possible for an and statement?
No,
Why not?
because it has to be connected.
Right, and has to be connected. So our answer for this one is
No.
no solution. So no solution goes with and or. And. Okay? So if you see that from this step right here, you don't have to graph or do anything else. You can just automatically put no solution. Okay? Questions with no solution. Okay, let's look at this example. Notice we have what? We have or. Keep that in mind. Looking at the left, what do we do first? Yep, we want to get x by itself. First we do. Yep, subtract the 1 over. So we have negative 8x is less than or equal to 16. Last step. Divide by negative 8. What happens? We're dividing by a negative. Sign flips. Good. So we have x is greater than or equal to negative 2. That one's done. Move on to the next one. What's first? Add 9. Because we have negative 2x is greater than negative 4. Last step. Divide by negative 2. We divide by a negative. What happens? Yep. Sign flip. So we have x is less than 2. Now it's or. We don't need to write it as a compound. Let's try and graph. Okay. What is this graph supposed to look like? They're going to go away from each other. Negative 2. Open or closed? Closed going to the right. Positive 2. Open or closed? Open and it's going left. It's not right, but can we still have this or this? Okay, so is there such thing as no solution on this one? No, so what's the other option if it has everything? All real numbers. So it's okay if or does connect, it just means it's all real numbers.